other than rectangular and polar forms, we also have exponential and trigonometric forms for complex numbers. Okay, so we recall the rectangular form in this format. So you have a plus jb or a plus bi. Okay, so then we have the polar form in this form. You have the modulus ri, and then you have the angle or argument theta I. And then for the exponential form, it's actually quite similar to polar form. So you get this one. Okay, you have the modulus ri, and then the theta or the angle in the exponent. Okay, so the exponent term. And you have the trigonometric form. We have that one. Actually, the exponential and trigonometric form are simply polar form. You can convert easily, or I mean, if you have the polar form already, okay, you can convert that one into exponential and trigonometric form, because if you multiply a polar form with the exponential form, you can actually convert easily, no, any of them, and then you combine them, and then you get a simplified version of the complex number. So basically, these two forms, exponential and trigonometric, are just polar forms. Okay, another way of representing the r angle theta. So but that's equivalent to re to the theta, and then or r cosine theta plus j cosine theta. This is actually quite familiar when we would like to convert polar form to rectangular form, the trigonometric form. Okay, so but another problem for exponential and trigonometric form is that you cannot use calculator mode. Okay, so there you cannot, if you encounter a problem like this in this form, so you cannot use your calculator. If you can remember your calculator, okay, so you have here your calculator. Okay, so if you shift complex, so you can see that there's no exponent. Okay, so there's only the argument, which is the angle conjugate of the complex number, and then you have the conversion to polar form, number 3, and then a number 4 conversion to rectangular form. You notice we don't have exponential and trigonometric form. And then if you use that one, exponential form, okay, so if you use to solve your calculator, if you use your calculator to solve exponential or trigonometric form, there will be error. Okay, so if you encounter problems with exponential and trigonometric form, make sure to convert them into polar form. Okay, so if you have this example here previously, so you have the rectangular form here, -1 plus 2i for the complex number x1, and you have the polar form here. And to get into exponential form, you just simply copy the polar form. Okay, so with the respective form of the exponential. And then for the trigonometric form, that's how you look at it. Okay, so this is very important, trigonometric form, for example, in the AC system of electric circuits, and also for mechanical one, if you have vibrations or if you have signal, no, so you will also represent that one with trigonometric form. And then you have the second complex number. Okay, if you can recall from the rectangular and polar forms, okay, so you have these two, okay, equivalent forms of the complex number x2. And we want to get exponentials, so just simply copy the respective modulus and argument. Then you can also express that one into trigonometric form. Okay, that's it. Very simple. Just remember two things. Exponential and trigonometric forms are simply polar forms. Second, that you cannot use exponential and trigonometric form into your calculator or using calculator. Okay, that's it.